Okie dokie. So today we will be talking about vehicle charging. And there is this term. Oh, hang on. Here we go. All right. Vehicle charging technology and electric vehicle supply equipment. This is EVSEs. So this is a pretty common term in the field to talk about EVSEs. This is like the charging infrastructure. We use this term instead of chargers, and I'll explain why in a moment. So thinking about all the sort of nuances between gasoline versus electric refueling, there's quite a sort of substantial difference, right, in the way that this happens versus the way that this happens. And so we're gonna really sort of dive into that today. Okay, so kind of like with the battery lecture, we're gonna have to go through a bunch of terminology and nomenclature as it relates to this thing or to these infrastructure. So, you know, if you go to a parking lot and you see this sort of thing set up, this is how we kind of refer to these things. So there's the connector or the plug, which is the head that connects directly into your vehicle. This entire sort of box here, this is known as the electric vehicle supply equipment. More casually, we might call this a charger. But in technical terms, people avoid this because the charger can actually be considered something that's on the vehicle itself, right? You have some of the charging supply equipment, the converter, the inverters inside of the vehicle. And so formally, in like the technical literature, you typically will see people refer to these things as EVSEs rather than calling them chargers. Yeah. Yeah, okay, so actually you'll see that a lot of these will have either two or these two different types, and we're actually going to talk about the different types of connectors or plugs. There's a specific reason for why you'll almost always see these two different types of plugs these days at EVSEs that aren't called Tesla. But we're kind of rapidly sort of migrating to just one now. But we'll get into those details in a second. And then, we'll talk about this whole thing, which is kind of a charging station. And it's kind of tricky here, right? Because when I gave you guys that question on the poll, which is like, oh, how many chargers are there in California? Well, am I referring to how many charging stations there are? Am I referring to how many of these EVSEs there are? Or am I referring to kind of the number of plugs? And that distinction is sort of mixed up and jumbled all the time. So it can actually be really tricky to kind of figure out, how many of any one of these three there are in when people measure these things. So what I'll say is what I was referring to in the poll is the EVSE. So that counts like multiple of these things at a particular station, but it's not counting all the plugs that there are, which you could do as well. And I have no idea what that number would be in California. It would probably be between 80,000 and 200,000, something like that. Okay. So let's talk about the different types of connectors. So the plugs. We've talked about different speeds of charging, okay? And so the level 1 and level 2 on the left over there. And then we have DC fast here. I actually brought in some of mine. You can pass these around if you want. Here you go. So this one here is a level 1. This one here is also a level 1. This is coming from a Nissan Leaf. You guys can just kind of play around with it, look at the heads. And this one is a level 2, which I just unwrapped it. This came with one of my cars, but I've never actually used it before. I didn't even realize it was level 2, which is a lot more expensive, so don't break it. I think you'd have a pretty hard time breaking it. But then what you'll notice about the level 2 is that the plug side of it, which I'm actually not even really going to talk about here, it looks different, right? That's for like a dryer plug. If you ever plug in your dryer, you'll notice that those have like a much larger head, and that actually operates at a higher voltage, which lets you have sort of higher power. And so that thing, you'll also notice that the cable itself is quite a bit thicker than the level 1. And that's, to designed to handle these sort of higher loads. Okay, so we're going to get into detail about all this stuff and what's in it. But generally, right, we have level 1, level 2. The heads of this one, which is the level 2, and the level 1 actually look identical. And well, they are identical. And level 1, these both operate on AC power, so it doesn't need a converter between what's coming out of the wall, right, which is AC power, and what goes into the car. And the car will have its own converter to go from AC to DC to charge the battery. At level 1, you're getting out of the wall socket about 1 kilowatt. You can calculate this using one of the sort of power laws. I don't remember the name of this law, but power is equal to current times voltage. Okay, so the volt, does anyone know what the sort of standard voltage of a wall outlet in the US is? $220 is too high, so that would be a level 2. What was that? I heard 120, yeah, so 120 volts. So if, where did I put my pen? All right, so if this is 120 volts, and this is approximately 1100 watts. So we can figure out the amps, right? The current that you would need to generate this. And you can kind of do these same types of calculations to figure out the power that you'd be getting out of like a level 2 as well. And to give a rough sense, again, level 1, you're getting a couple miles of charge per hour. At level 2, you might be getting a little bit more. And then there's this whole other thing about DC fast charging. So DC fast charging uses these 2 main sort of competing, CHAdeMO and CCS. And we'll get more into detail about this, but this is from the question earlier about why there's 2 plugs. Actually, there are a lot of times requirements if you want to build EVSEs to actually have both plugs available so that any type of car could charge there. Tesla obviously is a little bit different. Theirs is private and proprietary. So, I put them here because these guys constitute a lot of the number of plugs in the vehicles, right? And so, it's not like just because they're doing their own thing, these guys constitute actually quite a large number of chargers. Okay, so let's get into details about these guys. Okay, so charging standards. This is SAE J1772. SAE is the Society of Automotive Engineers. This is a pretty nice thing, right? The fact that it doesn't matter, again, besides Tesla, it doesn't matter which car you're buying, you can expect the ability to use this kind of standard in order to charge your vehicle. Having the standard is nice. It means that you don't have a diversity of different plugs among different automakers. And the standard itself is the interface for how you kind of connect to an electric vehicle. And you can see there's a bunch of sort of different form factors here. This one is similar to the ones that are being passed around at level 1. And level 2 typically will have some sort of larger controller here. And the plug will typically be a little bit different, as you can see by that one that was getting passed around. And so J1772 is the standard for both level 1 and for level 2 charging. Okay, so if you guys take a look, if anyone took a look sort of in the head of the charger here, you can see there's these 5 pins. Okay, and so those all have some kind of functionality. Okay, so you've got your ground here, and then the PP stands for proximity pilot. This basically tells you that the plug is present. Okay, and so if you actually look at the plug, the length of these pins are relative to the plug in the car are actually a little bit different. This one will come in contact first, so that and it will it will be the one to also leave first, because that by having it being longer, it'll be the first thing that the car knows that it's being connected. So you're not having any sort of like shorting happening between the connection. The control pilot here is the communication between the vehicle and the EVSE. These are not like complicated like signals or anything. These are going to be fairly simplistic signals to basically tell things like start or stop charging. And then your L1 is the actual line through which the power goes through. And then N is the neutral. So we can see here the level 1 and level 2, these both operate in one phase AC. So for those who are sort of familiar with how that works, and then you can see kind of the voltage for level 1, right, 120 out of our standard wall outlet, and then 208 or 240 for level 2, which is why you have some kind of variation, going between 6 to 7.2 watts of power. There's a misnomer here that a lot of people use, which is we say level 1, level 2, and then people often say, well, there's also level 3 charging, referring to DC fast charging, but that's actually incorrect. Okay, and when people say level 3, they're almost always referring to DC fast charging, but that is actually a separate term, because technically this standard gives you the ability to do what's known as level 3 charging, which is still AC. Okay, and so this doesn't really exist in the US because we don't have 3-phase with these voltages. But in theory, you could get sort of higher levels of power than what you would see out of here. You can get higher levels of AC with higher amperage. Okay, and so technically at level 2, I can get all the way up to almost 20 kilowatts. Not really a standard thing these days, although there are some, yeah, if you're good with your electrical engineering, you can make this happen. And actually we have some people at ITS who are kind of experimenting with this. Yeah.
So do you need a particular type of fast charging?
Yeah. Oh, DC fast charging. Yeah, that's not. Yes, you do need a different plug. Kind of. We'll get to that in a second. DC fast charging isn't really a thing at home. You would need some pretty expensive equipment. We heard some rumors about like, people at mansions who have, these big transformers to do things like heating their pools and stuff, where they could actually put in, transformers and the proper electrical equipment to go to do DC charging. But that's not really like a standard thing, right? That's like a pretty unusual. Yeah, so for home charging, it's pretty much going to be level 1 or level 2. Yeah. Yeah, so this refers to so the sort of sinusoidal property of AC power. Yeah, so two-phase electricity, it's kind of possible to do, but it's not a really sort of standard thing. Usually there are kind of specific reasons why, for example, we transfer power in 3 phases. Yeah, if you're interested in that, I would recommend taking like a power systems class. But yeah, I'll suffice to say that there are sort of physical reasons why we usually have 1-phase or 3-phase electricity. Okay, I do want to say, that with DC power, right? You see a lot of the power ratings are a lot higher. But the reason why we don't really think of doing this kind of thing at a sort of residential location, I think there's 2 kind of main things. One, it's really expensive, so it doesn't really make economic sense for a lot of people to do it. And 2, you probably don't actually need to have it that fast for residential charging. Okay, so let's say for at the upper end, $1,000, I get a level 2 charger installed at my house, and it runs at 7 kilowatts. That means when I go home and I park my car overnight, let's say 10 hours, right? Maybe I get home at, let's say you get home at like 7, and you leave for work at 7. So that would be 12 hours, but let's just say 10 hours, right? For ease of math, that's like 70 kilowatt hours that you could get out of your charger. That's gonna pretty much fully charge your Tesla if you were even coming in at like 0%, which most of the time you won't be, because the average amount that you drive is usually like 30 or 40 miles a day. So really at level 2, you would only need to charge, an hour or 2 a day, which, most of the time your car is just going to be sitting there anyways, right? So it's that, or it's let me spend on the order of $50,000 to $100,000 to install a DC fast charger. It'd probably be more than that actually for a residential location, so that you can charge your car in less than an hour, right? So that's usually why you don't see that happening. Okay, any questions about that? So that's all the AC power side of things. We'll now talk about DC fast charging. which obviously I have no examples of here. Like I can't bring in the whole EVSE. So those two charging standards that I was talking about, you've got CHAdeMO here, and then CCS, which we'll talk about in just a moment. The plug looks like this. It's big and it's heavy. So, you know, the size of this thing is maybe this big, and the cable, you know, is this thick, and it's a pretty hefty to kind of lug around. And this actually has a whole bunch of more pins here. The main ones are your DC plus and DC minus, which are the things that are essentially carrying the electricity into the car. And there are some things that are pretty similar. You do have a ground pin. This one has two separate start/stop charging signal sequences. There is something that grants permission to connect power. And then there's a much more complicated communication protocol between the vehicles. And one of the nice things about CHAdeMO is that this can, with the way that this is set up, it already allows for the vehicle to actually discharge energy back into the grid. So, you know, we're going to talk about vehicle to grid in another lecture. But this is the type of thing that would enable that to happen. It's not really a thing right now. No one's really sort of discharging back into the grid. But you would require certain types of protocols out of your connector that communicates between your vehicle to allow that to happen. So these two main things, CHAdeMO and CCS, they were competing for quite a long time, and a lot of regulatory agencies, for example, or if you wanted to get incentives and you're installing these chargers in public, you were required to build both CHAdeMO and CCS in order to ensure that both cars have access, which is why you have both types of plugs at a lot of these stations. CHAdeMO is used by Nissan and Kia. Wait, is it Kia? Hang on. It's Nissan and yeah, and Kia. But they're losing. See, a lot of their their newest vehicles are now sort of moving away from CHAdeMO. So in the kind of war between CHAdeMO and CCS, like everyone else uses CCS, Nissan and Kia use CHAdeMO, which isn't to say that, you know, volume-wise, right? Nissan Leafs were one of the most popular ones, so there was a lot of these, but Nissan's newest vehicle, the Ariya, doesn't even have CHAdeMO. It's using CCS. So I think most people see the writing on the wall for these guys. When you go to a charging station, you're still going to see this for many, many years to come. But I think that's, yeah, at this point, if I had to put money on it, yeah, I think we're going to pretty much just see CCS moving forward. Yeah.
2 lectures back, you mentioned that cars had ways to make sure that there wasn't, so the battery wouldn't get overcharged in a sense. Like so like, what kind of things are happening here for DC charging?
Yeah, so part of that is going to be natural to the like voltage of the battery, which will, you know, via some of the fundamental like physical properties will do that. But there are control elements in the vehicle that can provide signals to, you know, change the power level.
All the vehicles.
Yeah, but the vehicle's not. Yeah, okay, I see what you're saying. The vehicle's not off when you're charging it though. It needs some control elements, you know, the thing that provides the signals, communications, through the plug that requires some computers to be on. Actually, famously, Teslas are, I don't know if this has changed in more recent years, but with the like older Model S's, those things used a crazy amount of power. And oftentimes they would be turning on the car and having the computer running for, I have no idea why. But if you were charging with a level 1 charger in a Tesla, you would be getting a lot less than 1 kilowatt because the computer would be using so much power. Yeah, so these things are definitely on when you're charging them. And yeah, depending on the vehicle, some will use a lot less energy. I mean, the energy draw of like running a computer is like nothing compared to moving 4,000 pounds of, metal. Okay, so this is the other one, and you're going to notice something pretty interesting here. So this is called CCS, is the combined charging standard, and the head here is the J1772 head. Okay, so this is your L1, L2 connector plug standard, and then below that you have this really giant thing that dispenses this electricity. So it's an extension of the 1772 standard, and it has these electrical contacts that allow for DC power flow to happen. But it uses these types of things in the same way that the level 1 and level 2 charger have in order to kind of dispense that electricity. And the last one, of course, is Tesla. So they have their own standard. It's a pretty cool connector standard. These pins are capable of doing both AC or DC input. So you can do L1 or L2, as well as DC fast charging at the Tesla superchargers. And they also have, your ground, proximity pilot, and control pilot. Again, doing the same sorts of things, right? This is telling me that, hey, I'm plugged in, you're not allowed to move the car. This one is providing a signal communication, and you have your ground. Sometimes you'll actually see Teslas charging at other EVSEs or using like an L1 plug. And we say, how the heck does that happen? Like this obviously doesn't fit those, but they have adapters that allow you to use 1772 and CCS here. The Tesla supercharger network is pretty prevalent. I'm sure you guys have maybe all seen a supercharging station before. There's one right by the Safeway with a bunch of Teslas parking back there in South Davis, right? And actually, a lot of governments are now kind of requiring standardization. So Tesla stations in the future may require the presence of CCS chargers to support other types of vehicles. And in fact, in Norway, a lot of the Tesla stations were basically forced to switch over. And there's like pros and cons to that, right? Tesla, it makes a lot of sense to have one standard so that everyone can use it. But then Tesla spent a lot of their money to develop their sort of proprietary technology. And so there's a question of, how sort of fair that is, which maybe we won't get too much into. But actually, just because Tesla stations would have, for example, CCS chargers, doesn't mean that they can't still sort of favor their own vehicles in some way, right? Like they might get priority in the queuing system for using Tesla chargers, things like that. So there is still some competitive edge being retained there. So for the DC fast chargers, we've only been talking about this sort of plug thing, right? But the stations themselves are, these big, much sort of larger types of things than what you would see for level 1 or level 2, right? So the level 1, level 2, it's these, thicker wires, right? And for level 2, oftentimes you might have this little box controller. But for DC fast charging, there's a whole bunch of other stuff that happens, right? You have to have these really high voltages. You need to go from AC to DC, so you need these inverters. And so when you see these sort of big boxy units, usually that's a pretty good indicator that you've got DC fast charging. There are countless already sort of different players in the game now making these things, and it's not really easy to tell just by looking, for example, at these, how fast they run. So these guys here, these are sort of your older generation 50 kilowatt fast chargers, right? These guys go double that. These are 100 kilowatts, and you can get even faster, right? So these go anywhere between 150 to 175. The Tesla ones, a lot of the super fast chargers, like first generation, were usually 120 kilowatts, but now these guys can go as high as I believe 220 to 250, something like that. And then, as I was mentioning, the sort of gold standard for the highest rates of charging is 350 kilowatts. Just last year or the year before that, when I'd be sort of teaching other classes talking about this, I'd kind of joke that 350 kilowatts, that's crazy. A lot of them, they require some like liquid cooling in the wires, and there's no cars that could even come close to being able to charge at that rate. So even though you had 350 kilowatts, most cars topped out at 150, but not true anymore. There are a handful of cars that are already able to fully utilize 350 kilowatts. So that's something like, as I was mentioning before, going up to like 80% is usually how a lot of people measure this. So I can go from 0 to 80% in like 15 minutes for a 300 mile car. Okay. As I mentioned before, right, when we were talking about the battery lecture, that when I say a 350 kilowatt, 150 kilowatt charger, that doesn't mean you're always going to get that speed. And so anyone who's charged an electric vehicle will know this, right? If you kind of do the math and you're like, oh, I have a 50 kilowatt battery and I charge at 150 kilowatts, oh, that means I should be done in 20 minutes. And if you try it, I guarantee you won't finish in 20 minutes, right? Because of the issues with the battery voltage changing and some of the sort of controllers in the car decreasing that. But there's another thing. If you are at a 150 kilowatts charger at a station and you're charging by yourself, maybe you'll get that full 150. But maybe 10 other stalls are occupied and everyone's drawing power from the same place. Depending on the electrical infrastructure that's installed, there could be like a peak power capacity for the entire station. And so that may decrease your ability to get sort of full power because it's getting distributed amongst many vehicles. You guys might have heard recently, President Biden made this big announcement that they're going to install a network of chargers across the US. They want to install a charging station every 50 miles along basically all of the major freeways. And for those ones, they're actually requiring a peak capacity of 600 kilowatts, which means that you could with four plugs, you could get a full 150, which is actually quite a bit of power. So one sort of nuance that you have to sort of contend with when we think about sort of how fast the charging speeds at a station is. And that's not like easy data to come by, right? So there are apps that tell you where the chargers are. The one that I use is called Plugshare. It's a sort of crowdsourced one. And you can look on maps and see, okay, how many plugs there are, and how maybe sometimes they'll even tell you, how frequently it's occupied. You'll get information about, how much it costs to park or charge there. But this kind of information is a lot less straightforward to try and glean from regular users of these stations. All right, any questions about any of this? Great. So even though we've got a couple standards, there is some complexity, right, between level 1, level 2, DC fast charging, the different types of DC fast charging. So for new consumers, it can definitely be a little bit overwhelming. And so part of learning about these things it's an important sort of process to get people comfortable with how charging works. And unfortunately, that it can continue to get more confusing because that's just in the US. There are different standards in other parts of the world. And that's not just because, hey, like I'm Europe, I want to do things differently, right? So that the electricity grid in Europe is actually different from the US. They operate at a different sort of baseline voltage, right? And so there are nuances of the design that have to take that into account. So I'll just really quickly say, in the EU, where you're operating at 220 volts instead of 120, they use what's known as a type 2 connector, which is kind of the equivalent of it's the analog of the J1772 in the US. And they actually allow for 3-phase power, and there's a whole bunch of sort of different configurations here that you can see. And so I'm not going to go really into the details here. You can kind of reference the slides if you're interested. But this is kind of the universal standard in Europe, and it allows for a bunch of different sort of power configurations, including DC fast charging. Actually, there are some even that use these pins differently that allows for DC, lower voltage DC power flow in the connector. Yeah. Yeah. Yeah, actually, that's a really interesting question. I haven't thought about that before. That must be problematic. It's kind of interesting though, because my understanding is actually that US had, so in earlier years, US had actually exported a lot of their EVs to Norway. So I don't actually know how they dealt with this problem. I will ask around because that's a pretty interesting issue. I don't think there's problems if you were to like export to like Mexico or Canada, because those grids are going to be the same. But if you are doing exports to places with different power grids, that will be problematic. I know that like, so I'm saying problematic like institutionally, right? If there's a lot of that happening directly from the automaker, I assume that they would just be producing, you know, these on a certain number of vehicles. Individually, this type of thing definitely happens, but you can buy like converters or the adapters, sorry, not converters, adapters on a lot of the plugs to allow you to, you know, get around this. But obviously you wouldn't want to do that at a really large scale. That's more for like if an individual is really interested in getting a specific EV in a different location. So yeah, interesting question. I'll have to look into that. Okay, so this is more kind of as a reference sheet. I didn't really talk about the other end of these. So the plug types for your level 1 and level 2 will look something like this. So there's a bunch of different standards there. And then these are all your sort of common connector types. So we've gone through most of these guys, right? So 1772, CCS combined standard, the type 2 and CCS type 2 in Europe. And then you've got your CHAdeMO connector and your Tesla connector. So a little bit more detailed information here. If anyone's interested, they can look into the slides. And then, okay, yes, here, as I was mentioning before, who uses what type? Tesla obviously has their own. And then you've got CCS, everyone else basically uses CCS. And then CHAdeMO, I guess Mitsubishi had some old vehicles that did that. But Nissan and Kia are kind of the bigger players in the EV world, especially Nissan, I would say, in the last decade. But again, both of these guys are migrating to CCS. And so really, I think CCS is going to be essentially the dominant standard. When you go to EVSEs, you're still going to see CHAdeMOs around for quite a long time. A lot of the requirements, if they want to take advantage of like certain credits, these service providers still have to put in these plugs. Okay, any questions? Okay, why don't we take a quick break here for 5 minutes and we will reconvene. All right, we're getting back to action here. Okay, so we talk about infrastructure deployments. This is I think this is actually when we visited. So a lot of these automakers have to test out a bunch of this equipment, see how robust it is, if it'll affect the vehicles in adverse ways. So they've got these like buildings full of these different devices. Most of the level 1 stuff is just kind of like what I was passing around. But a lot of the level 2 have these sort of charger boxes. So these are all different sort of L2s being made by different manufacturers. So as I was saying, there are a lot of players in this game already. Lots of different equipment. Some are better, some are worse. Yeah, and so you can imagine there are a lot of cars in the world. People want to get in the game however they can. And so in this area, while I was mentioning, right, 80,000 chargers, public chargers in California, well, 80 to 85% of charging actually happens at home. So you can imagine there's a lot more of these guys than there are even the public chargers. There's about 1 million electric vehicles in California right now on the road. And you know, not everyone is a, you know, homeowner. You know, there's some that are going to be coming from apartment complexes, MUDs, that sort of thing. But at this point, a lot of them are homeowners and a lot of them have these sorts of things. And so from a sort of infrastructure perspective, we don't usually talk about this as like infrastructure, but it is, right? So these chargers are far more widespread than any of the public stuff that we see today. And speaking of that, there have been some studies, actually this was a recent one, I believe, coming out of, I'm gonna get this wrong. It was either the PUC or the CEC. I think it was the CEC report, California Energy Commission, trying to figure out, okay, more and more people are buying electric cars, and it's not just gonna be people who own their own homes. And so they wanted to look at, you know, people who possibly have access, right? And so people with existing access, so single family homes, multifamily homes, and everyone, right? So if we add these together, right, we can see and how this sort of changes. So potential access, like if you built it out, how many what percent of the population could have it? Like existing access with like behavioral modification. So we make people change the way, the locations where they park, that sort of thing. So we're probably sort of still tapping into these bars here, right? But as you have more and more people with electric cars, you're gonna run out of the sort of easy thing of existing access, and you have to start moving in this direction. And so how might that change over time? What sorts of things can you help do in order to improve access to home charging, right? And so they talk about sort of education, the actual infrastructure installation, changing the way that you park, and making up sort of larger and larger chunks of residential charging availability. This is kind of the area where a lot of work is being done from an infrastructure perspective to improve access these days for electric vehicles, right? And so there is this challenge with the affordability of electric vehicles. When we talk about, you know, it's not just rich white people in Silicon Valley buying these things. We want them to go to other, you know, other populations. But it's also a double challenge to make them comfortable and give access with charging as well, where it might be a lot more challenging if you don't have like your own home. Okay. So the other place where infrastructure is deployed commonly is at work. Companies have been providing workplace charging as an employee, as an incentive or benefit if you're working there. Yeah, and so I take advantage of this so I work at the Institute of Transportation Studies, which is located out by West Village, and we have kind of our own chargers installed, which is free, which is great. So ever since I've switched to an electric vehicle, I basically haven't had to pay for gas in forever, which is a nice perk, right? But there are these kind of charging etiquette at a lot of times, specifically at workplaces, that you have to navigate, which is pretty interesting. Oftentimes, you get what's in the EV community, it's called getting iced. So ICE, right, is an internal combustion engine vehicle. So if someone with a gas car parks in front of a charger and blocks you out, it's called getting iced. So that happens all the time. You sometimes will run into this thing where, okay, what if someone else is charging and their battery is full? Can I unplug them and then plug in to my car to charge up? Like, is that allowed? What about if the other car is a plug-in hybrid? So I know that they don't actually, that they have like backup with gasoline. And then let's say I'm really low on my charge. Am I allowed to unplug them and plug my car in? Right, there are all these little things that you kind of have to navigate, which is pretty interesting. I mean, it's going to become more commonplace every day. Yeah, and actually, cars themselves have these built-in mechanisms to prevent that. So I actually packed them away already, but here, I'll grab one really quick. So these chargers have this little clicky thing, latch, and the car can actually lock the latch in so that you can't remove the charger. That's nice for like this type of equipment where you own it, and so people can't just steal it from you, right? They unplug it and then take it away, because these are actually worth like a couple $100. And if you're at a public charger, it means that they can't actually unplug you and plug themselves in, right? That latch and lock system prevents that. So in most vehicles, the lock will unlock if the vehicle is full, which is sometimes like an indicator that, hey, it's okay to like take this out. You can also, as a setting, choose to leave it unlocked, which oftentimes, from an etiquette perspective, you interpret as, hey, I'm charging right now, but I don't actually need it. So if you need it more than me, I left it unlocked, go ahead and unplug it and use it if you need to, right? So again, there's this whole interesting thing that's going on. And at work, sometimes I've heard of, you have these like sign-up sheets about what days you're allowed to do it. And there's other things like you're expected to, if it's fully charged, you have to move the vehicle so that someone else can use it, all this stuff. So getting a little bit sort of complicated from that perspective. But at the end of the day, it's like a big perk, right? I can just go to work and charge, don't have to go to a gas station. And a lot of times, the vast majority of times, workplace charging is free. And so, free fuel, think about how much you're paying for gas these days and how much money we would save if you had this. Yeah, and for a long period of time, I didn't actually even have any home charging. I was just charging at work, but that was fine and better actually because it was free. The last one, infrastructure deployment, is just your regular old public charging. So I'm sure people have seen these by now. Chargers at in lots of sort of different locations. A lot of companies will either have something like this. So ChargePoint is a service provider, and their business model is they sell the infrastructure to whoever wants to buy, to their customer, and then the customer retains control of all the like pricing and charging and everything. That's one type of thing. So Target, for example, oftentimes has buys a lot of charge point chargers, and then they control whether or not it's free and how much they charge their customers. Whole Foods is it uses a partnership with EVgo, and that is a slightly different model where there's kind of EVgo still retains all of the sort of service provision aspect of the charger, so they get the revenue from charging the vehicles. A lot of Electrify America and sometimes EVgo at Walmart's, IKEA. A lot of the ones that I've seen have these Blink chargers. And then there are certain sorts of use cases for public infrastructure that's kind of really nice when you think about their deployment relative to how like gas stations would work, right? So again, it's this idea that like, I don't want to go to a quote unquote gas station or EV charging station and sit there for a couple hours waiting for my car to charge. But oftentimes they do it in locations that sort of intersect with services that you would use anyways, right? And so, okay, this is the Whole Foods one. If you go to like Arden Arcade and you go shopping, right? They have chargers there. You might be shopping for a couple hours. If you go to the movie theaters, right? This is kind of a natural place to do it as well. You're going to be watching the movies anyways. Might as well be charging your car. All right, how many? Oh yeah, sorry. Go ahead.
Do they do anything like this for apartment complexes?
Yeah, that's a big one. So that's, I would consider back in the world of like home charging, residential charging. So, okay, if I'm a landlord, like why would I install a charger, right? That's like this is like a fundamental difficulty. This is actually a big thing in energy efficiency too, right? Like what incentive does the landlord have to like give you energy efficient appliances, which means you save money, but it costs them more upfront. Same type of issue. So to get around that, there are a lot of like policies and regulations to try and address this. Utilities, for example, offer these really big credits to incentivize apartment owners to install chargers. And it's getting to a place where maybe the apartment owners themselves have electric vehicles. Maybe they're seeing the added benefit of like how attractive the apartments are getting by installing these. So there are some signals that are helping push like landlords and apartment owners to do these, but it's still like a big challenge. It's one of the bigger challenges I think that CEC, the Energy Commission and the Public Utilities Commission and even the legislature, yeah, we're always talking about like different ways to address this issue. And then, yeah.
Just thinking that like I've heard that like some of these private companies will charge you for the time and using the slot and the fully charge.
Yeah, I'm going to talk about that in a second. We're going to look at some of the like rates that you would get charged. But yeah, that is an interesting one. We had talked about it amongst like the research community like many years ago, and now they're actually doing it, which is pretty funny to see. Okay, how many chargers are there in Davis? Who wants to guess? Say, sorry, what was that? Public chargers. Who says more than 10? How about more than 20? More than 40? So here's all the locations for chargers in Davis. A lot of them are university, but quite a bit sort of throughout some of the more public areas, right? A lot in downtown. The orange ones, so okay, this is coming from the Plugshare app that I was talking about. This is a really nice app. Eventually, I assume everyone here at some point in their life will be owning an electric vehicle, maybe. And when you do, I highly recommend this. It's crowdsourced and updated much more frequently than and sort of individual ones. And so I'm going to talk about like service providers, which is a pain because you have to navigate through like 15 different apps of different service providers to find their chargers, whereas this is all kind of laid out for you. And there's a lot of convenience things here too. They like tell you what services are nearby, like are there restrooms, are there restaurants, what kind of shopping, how much it costs to park, all that information. So I'm not paid by Plugshare or anything, by the way. It's just a good app, so I'm going to advertise them. Okay, so the orange locations, these ones are DC fast chargers. So you'll notice that there's a lot less DC fast chargers than there are level 2 chargers. So everything else is pretty much level 2. There's not really level 1 public charge. I mean, there are in some places, but it's pretty rare now. Yeah, and so you can see like at Target, there's a bunch of chargers at Target if you kind of pay attention and you go through their parking lot. Down here, these are actually a lot of the chargers at the dealerships. Oh, I didn't even know there was a DC fast charger there. Cool. Yeah, so you can see, and probably this already looks different since I took a screenshot and put it on here. In California, this number is already 80,000, not 75,000. And there's more than 10,000 DC fast chargers, although the vast majority of those are Tesla superchargers. So that metric will be different depending on which car you have in terms of availability and accessibility. And so for reference, right, there are about 8,000 gas stations across the state. So there's actually already more public chargers than gas stations, but again, it's not like an apples to apples comparison. Gas stations are very different, right, than electric vehicle charging stations. But oftentimes I show these maps and it's a lot different than what people sort of have in their head already. Yeah. Yes. This number, I'm pretty sure is EVSE. Yeah. So each like box. Yeah, but that's again, it's like very confusing, and people always talk about different things when they refer to these numbers. But I'm fairly certain this is the like box itself, right? There's actually a nice paper about this that talked about the sort of discrepancies in numbers and depending on what you were talking about when you say a charger. Yeah, and then across the US looks something like this. I mean, you can't really kind of tell exactly what's going on. It's very sort of dense, right? But there's a lot of chargers in the US, and more than I think most people think. Yeah, you can kind of see some of the like highway networks lined up like this. And it's about to be a lot more dense, okay? So we'll talk about some of the policy stuff at the end of this course, but I'll quickly mention that in California, the governor made an executive order a couple years ago, sort of promising 250,000 public chargers by 2025. It's since been a couple years later, and we're now at 80,000. I think it was at like 20,000 when he did that first executive order. Don't quote me on that. But now we're sort of well on our way, but you can see the speed of which we're expanding this. So that means basically in 3 years' time, that number will triple. Okay, so we'll have 3 times as many public chargers in 3 years. And then on the US side of things, I mentioned that you have to have a charger a charging station every 50 miles, and they just put $7.5 billion into it. So yeah, we're going to see a whole bunch more chargers popping up sort of everywhere. Okay, let me see. Do I talk about? Huh, yeah, okay. I guess I don't even talk about the service providers, but maybe here we can talk about it. So there are different network providers. So these are probably some of the most commonly seen. So Tesla far and away the most. And then you've got EVgo, and EVgo mainly specializes in DC fast charging. So most of this is going to be DC fast. ChargePoint, Green Lots, Electrify America. Electrify America. So this is in 2019. Yeah, so Electrify America, that's actually coming, a lot of the funding for that is coming out of money from the Dieselgate scandal from Volkswagen. And it's finally, going back to the public here. And Electrify America has expanded quite a bit in the last couple of years. So you can be sure that this guy is definitely a lot bigger. The Blink network is kind of an interesting one. This is a cautionary tale. Back in the early 2010s, there were these incentives for people to install chargers. What was it called? Ecotality. Yeah, that was this company that basically threw down all these chargers everywhere. They didn't care that they would be in really bad locations. They didn't care about maintaining them or anything. They just installed them, deployed them so that they could get the subsidies from the government, and then basically went bankrupt immediately afterwards. And so Blink is one of the networks that ended up buying out some of those chargers. Interesting sort of tidbit of history there. Yeah, and so this is also kind of what I was mentioning. Oh yeah, go ahead.
How strong do you think especially
Yeah, it can be a tough sell. It's funny that you mentioned that as well. Actually, we're currently in the midst of doing research into that exact question. What is the business model for charging infrastructure? So we're going to look at some of the economics in just a second, right? But you're talking about, okay, I'm going to plunk in this DC fast charger. It's going to cost anywhere between $50,000 to $100,000. In some cases, a couple $100,000, depending where you put it. Okay, so for like a business, typical payback period, right? You want to make the money back for your investment in like 2 or 3 years. That's like a pretty standard operating procedure, right? For like investments. So what do you have to charge, and how many cars need to be using your service to make up that money? From an electricity perspective, I've always, like, you could do these back of the envelope calculations. I've always found it pretty difficult to make your money back, because you're talking about 20 to 30 cents per kilowatt hour, right? And if a car comes in, let's say I charge up 50 kilowatt hours, right? So times, let's say 20 cents. So that's, $10 a pop, right? And so you're talking about making on the order of dollars per day to make up hundreds of thousands of dollars over the course of 3 years. So the business case, I think, is really challenging, but I think there are possibly alternative ways you could do this. Membership fees. Also, if you are a restaurant or you're a business, you're going to maybe you use that as a way to entice customers, right? Because you're going to make a lot more money selling a meal than you are selling the electricity. back to the car. And so there are lots of sort of interesting opportunities to sort of generate revenue related to charging vehicles that are going to be really sort of non-traditional. Yeah, that's a big project we have just launching right now, actually. Yeah, and so this is a breakdown by percentages. This is, you can see that there's so many companies here. They do this really nice thing in Norway where basically all the network providers are required to register with the government. And then when you get an electric vehicle, you get issued this little key fob, and you can use that anywhere to access a charger. In the US, it's such a pain because I need an app for EVgo, I need an app for ChargePoint, I need an app for Greenlots, an app for Electrify America. Yeah, if you look at my phone, I have a little folder, with just charging network apps, and it's just like, sometimes they go bankrupt and I have to delete the app. It's very annoying. Yeah. Okay, so let's talk about how much this stuff costs. Yeah, so there have been some studies that have looked at these. And so these are kind of average costs here, but these can vary a lot. Okay, so a level 2, if you have to upgrade your circuit breaker to put in more amps, that's going to be expensive. But if you have enough sort of spare capacity in your circuit, and you just need to sort of buy the box, you could install it yourself and not have an electrician, and that's going to save you probably a couple $100. So this can be anywhere, I would say, from reasonably, so like $300 on the really cheap end if you're like DIY and you buy the equipment on Amazon, that sort of thing, up to, let's say, I want to say like $2,000 if you are upgrading your circuit and you're hiring an electrician and all of that. So something a bit between those. Those costs will be kind of different for public. So this is still level 2, but in public. So you can see, the labor might be quite a bit higher, right? And then you might use slightly more robust hardware, especially if it's like outside, outdoors. If you do curbside installation, this can be quite a lot for labor. A lot of this might have to do with, digging a trench for your wiring, right? That's just a lot of labor costs. So I would say outdoors, or not outdoors, so public L2, you're talking on the order of several $1,000s, which is pretty reasonable, up to as high as, let's say, $10,000, which is really kind of quite on the high end, but not totally unusual. DC fast charging. So this is the sort of, I would almost argue, kind of low end here. Okay. So definitely gets more expensive at higher charging speeds, right? This is coming from an older report. And so this is like a 50 kilowatt charger. Once you're talking about 100, 150, some of the stuff upstream that you need of the charger gets a lot more expensive. So that EVSE, that box that you see with the DC fast charger, there's a whole bunch of other stuff behind that sometimes components of it that the utility has to end up paying for. That's a lot of costs there as well. So you need a high voltage transformer. You have to have the converter from AC to DC. And that's very expensive electrical equipment. And then oftentimes you have really big sort of labor costs to lay conduit into the ground, to get like permitting. All of this stuff is fairly expensive. So even though here we're talking like 50, 60, 70, I will kind of say that this is probably more on the lower end of the costs. Here, we're giving kind of a breakdown and in a little bit more detail. I won't get into this too much, but you can see that there are lots of different components here that aren't as applicable when you're talking about sort of home charging, but can really sort of add up in cost once you're talking about these high power chargers. Yeah, and so I'll leave this table as kind of a reference for folks who are interested. When people talk about installation and deployment of EVSEs, you'll often hear this term called make-ready infrastructure. This term in itself is has kind of a loosey-goosey definition, but usually what this is referring to is like of your EVSEs, you can actually see there's a whole bunch of things behind the scenes that are happening. And so you have a load center, power distribution, you've got the meter to measure how much electricity is actually being drawn. You have a transformer, usually going to be a step down transformer going down to lower voltages, overcurrent protection. And so make ready, we typically refer to as all the stuff that needs to go into place so that you can just plop in your EVSE unit, right? And so once everything's in the ground, that's all the make ready stuff, and then you have the last bit here. Yeah, and again, depending on the site, things could be really different. We worked on, projects with Caltrans like rest stops where they just don't even have access to electricity. So then they have to either bring in power lines or they have to install like a independent unit, like you could have like a storage unit with solar at that parking lot, right? So that you can still operate independently of the grid. And that's tremendously expensive, right? And then which portions of these guys here are the service providers paying for, and which portions are the utilities paying for? And so, that is actually, fairly well established. But the stuff that the network service provider pays for, like Tesla or EVgo, that's going to get wrapped into the electricity rates that you're paying for when you charge your vehicle. And then the stuff that the utility is paying for, that gets amortized to everybody, right? And so if the utility puts in this transformer, the service provider doesn't see that cost, but everyone else in PG&E is essentially going to be paying slightly higher rates, right? And so there is some things related to equity here. It's like, I don't own an electric vehicle, but my electricity rates reflect me kind of subsidizing infrastructure to pay for people who are charging their vehicles. So that's kind of an interesting problem these days as well. Yeah, so as I was mentioning, installing the EVSE, trenching, conduit pipeline, wiring costs can be a really substantial portion. So I was mentioning I have a grad student who's working on analyzing the sort of costs associated with installing chargers at rest stops. And this is like the parking lot for a rest stop. And this part right here, so a lot of the electrical equipment is here, but the cars are parked over here. And so they're putting the stations right here. So you have to do this trenching here, and that costs like hundreds of thousands of dollars. The fact that like you have to go from here to here, and that's like a huge increase in cost. Like the bulk of the deployment costs can end up being this construction that has to happen. The other tricky thing about rest stops, right? So if you're driving down Highway 5 and you're heading to LA and you pull off on the rest stop and you're going southbound is the rest stop for southbound the same as the rest stop for northbound? No, right? It's like on opposite sides of the freeway and they're not connected. So when you build one here, there's a rest stop over on the other side of the freeway that has to, that if there isn't electrical access on both sides, they like tunnel under the freeway. So imagine what those costs are going to be, right? So in that project, the student is finding, you know, where I was saying 50, 60, 70,000 is kind of like on the low end, you know, they're finding projects that cost $500,000 for a charger. Okay, so let's talk about rates. How much do people pay? Okay, so if you guys are here, I presume that you're either in PG&E or you're in SMUD. So these are the sort of different rates that you see. We used to have this type of thing. So these are tiered rates. So if I use, there's some kind of like baseline cutoff. If you use some amount, you pay that amount. And then everything above that, you pay a slightly higher amount. And then everything above that, you pay a really high amount. So those tiers used to look like this: 26 cents, 33 cents, 41 cents a kilowatt hour. Now everyone has essentially been moved off of that to time of use. And that looks like this. It's a little bit complicated depending on the season that you're in and depending on the tier. So there's still kind of a tier, but it's based off of the time of the day. Basically, you want to avoid using electricity from 4 p.m. to 8 or 9 p.m. Those rates will usually be higher. That has to do with some particular ways, some particular nuances of the electricity grid. It costs them more money to generate power at those times. Does anyone know why? Has anyone heard of the duck curve? Okay, so all right, I'll get into this really quick. So California has a lot of solar power, and that means that we generate a whole bunch of power from the sun, and then the sun starts going down, you know, at 4 o'clock to, you know, the early evening. All these solar, all the power from solar generators, solar panels rapidly starts falling off, and everyone's still using electricity. So a bunch of other power plants have to suddenly turn on to deal with this issue. That's it makes the shape of a duck, which is why they call it a duck curve. And so utilities try and incentivize people not to use electricity during these times. And so that's called on peak, like try and use less electricity, otherwise you have to pay more for it. So PG&E, they have a bunch of different rates here. And then Sacramento, SMUD, they have a bunch of different rates here as well. So you can see what those look like, right? In the peaks, you still have these peaks, right? 5 to 8 p.m. and those cost more. Although, yeah, from paying electricity perspective, SMUD is quite a bit cheaper than PG&E. Yeah, and there are sometimes these utilities will offer sort of special rates for customers with plug-in electric vehicles. Those will be, you know, extra special because they want to get people to charge their vehicles at a certain time, because vehicles use a lot of electricity. So it's like it's more compelling for them to try and, you know, push people to charge at certain times of the day. Okay. So that's the kind of home electricity stuff. In a later lecture, we're going to look at this a little bit more closely when we think about the sort of cost to consumers, to drivers. Like, we're going to do comparisons of like this against gas cars paying for, you know, gallons of gasoline. But for now, you know, I'll just highlight these kind of rates. Okay, what about charging in public? Okay, wait, before I do that, let's just have a couple of these numbers in mind. So we're talking about in PG&E, you're on the order of between, let's say, 25 cents up to as high as like 40-ish cents. Okay, but usually high 20s, low 30 cents per kilowatt hour. And okay, a lot cheaper in SMUD. Okay, so let's see how that compares to what you would pay when you're charging at a public station. Okay, so I've kind of picked out a couple of the biggest guys. So Tesla, Electrify America, and EVgo. So for Electrify America, if you just roll into the station and you start charging, it's 43 cents per kilowatt hour. So that's really kind of on the upper end of what you'd be paying if you charge residentially. But if you are a member, you get 31 cents. So you save 25%, but there's a $4 monthly fee. So you gotta like work out how often you're gonna charge at Electrify America to see if this makes sense, right? EVgo, similar types of things. They have a pay-as-you-go. So 29 cents per kilowatt hour, and you're like, oh, that's so much better than Electrify America, but there's a session fee of $2. And then you can also pay $3 to make a reservation. So again, you kind of have to do some math to figure out if that makes the most sense. You can do it as a member, which negates the session fees. But there's like I think EVgo is like $7 or $10 a month, something like that. I don't remember exactly. And then you can have some EVgo Plus. I don't know what kind of membership you need to do this, but okay. So a couple things there. Tesla, they have some weird charging rates. So depending on the power level, you can have, they charge not by the kilowatt hour, they charge by the minute. And that's actually an interesting nuance that I'll bring up. So this gets into some like legal ramifications. So PG&E, SDG&E, all these utilities, they provide you electricity. They're the only ones who provide you electricity, right? You don't get like a whole bunch of different utility options. There are CCAs and that stuff, but let's not, we won't get into that. And what if they were just like, okay, tomorrow I'm gonna make you pay like $3 a kilowatt hour, right? I'm in control of your electricity, you have no choice, you have to buy from me, right? They're not allowed to do that. There is this thing called the Public Utilities Commission. There's a regulatory agency. They determine the rates that are set by the utilities, and it is illegal to charge anything other than what's been approved by the CPUC for electricity. Okay, but now you've got all these guys here who are selling you electricity, and they can price it at whatever they want, right? So there is this issue with the CPUC that actually, the PUC is the one who determines these rates. And so they get around this by saying, we're not actually selling you just electricity, it's like the service. So you're paying for like the parking spot too. That's kind of the justification for being able to charge other things, or, right, charging by time, not by electricity. Yeah, and so if you look at the rates by time, so you charge at a slower charger, faster charger, super fast. The faster that you charge, the faster the power level is for Tesla, the more money you pay per minute, but you are also getting more power per minute. So if you do the conversion, it ends up looking like this at the 17 cents per kilowatt hour, 27 cents, 28 cents, 32 cents per kilowatt hour by Tesla. There was also this thing that was mentioned earlier that Tesla does a pretty interesting thing, and I think some other companies are starting to do this as well. It's hard to keep track of what everyone is doing, but basically, you charge your vehicle and you're just sitting there, and other people need to use the charger, and you finish charging, but let's say you're still munching away on your food in McDonald's or something, and your car is done charging. Tesla will now charge you extra money for idling and using that charger when someone else could be using it. And they charge you a lot. This is like 50 cents a minute, $1, $1 a minute after you are done charging, which can cost as much as what you'd be paying when you're charging, right? So that's their way of kicking you off, making sure that you get kicked off the charger as soon as you're done charging. Okay. All right, okay, I guess I had a slide on this. Business case of EV chargers. Yeah, so I already mentioned this. It's a pretty interesting topic and something that's actually I'm doing some research on right now. Okay, I always get lots of questions about other sorts of things, other sort of futuristic modes of charging. And so let's talk about those to close out the class today. Wireless charging. Okay, what is this? So, kind of like, I don't know if anyone uses, wireless charging for their phone, same type of idea, but at a sort of much larger scale. This uses electromagnetic induction. So you can generate magnetic fields in order to generate electricity. So through inductive coupling, it creates an AC current in some kind of induction coil in the vehicle. Not a theoretical technology, right? This definitely exists. Lots of people already do wireless charging with their phone, for example. There are some technical challenges. So these are more expensive than the chargers that you would use just to plug in. There's a question of like, okay, like how much effort is it to just plug in the vehicle as opposed to kind of driving over and kind of making sure your vehicles is exactly centered in the right way. So from like an economics perspective, there's this fundamental challenge of the higher cost there. There are some technical issues with, so the gap between the induction plate and the vehicle can lead to low efficiencies. So you're drawing a lot of power here, but you're not actually putting that much into the car. You get low efficiencies. And yeah, that can be sort of problematic for wireless charging. So in my opinion, I think that these things I think that there will be a market for this. I don't think it's going to be a really big market. I think you'll see these things around in some locations. Maybe this will be more of like a luxury type of thing. But I don't expect this is going to be like something that would take over the existing market of chargers today. The other big one that a lot of people like to talk about is battery swapping. So this is kind of reverting to a gas station model and the convenience related to that in terms of speed. Let's say I pull into a station and the idea is basically take out the battery of your car that's empty, swap in a new battery that's fully charged, and then you get to drive away, and that's a lot faster than charging. And then the station owner can be the one who charges the battery for the next vehicle. This I am not a big believer in. But again, this is something that I could definitely be proven wrong on. There are companies that are actively pursuing this. But from what I've seen and studies that have looked at this, so sort of irrespective of the technical challenges, which is like, okay, the automakers have to kind of maybe come together They also have to design the vehicles differently to make the batteries really accessible. And then are you going to have like a similar battery design so that you could swap them for across different automakers and brands? Or do you need to hold like 10 Tesla batteries and 10, Chevy batteries and 10 Nissan batteries, that sort of thing. So even irrespective of all of that, there's like a serious economic problem with doing this. The like flow of cars coming in and the number of batteries that you would be required to hold in stock, and then compared to the money that you would charge to swap out the battery, like the economics, I've never seen it really kind of work out in a reasonable way. If you expect more vehicles to be coming through your station, you need a larger and larger stockpile of batteries to be able to swap. And that's just like really expensive, right? The battery is like by far the most expensive single component of the vehicle. And so the idea that you can have a giant stock of these to run this type of business, at least from the analyses that I've seen, make very little economic sense. Yeah. I mean, they have, so as I understand, the battery swapping that's happening in China is oftentimes with like fleets that are owned. So that's a little bit different. It gets around some of the sort of technical challenges, but still, I think that the sort of economic model behind even those existing operations isn't even great. Yeah. Again, like I'm gonna say that's kind of my personal opinion, and based off of what I have seen in sort of studies and the business models in the real world, I could definitely be wrong about this. So don't be surprised if someone's like laughing at me in 5 or 10 years and everyone's doing battery swapping. I don't know. It doesn't make much sense to me. And then there's this guy here. Let me see, does this work? I don't know if you guys have seen this before. This is kind of, actually at the time, this was kind of like a joke type of thing. But actually, people have started seriously talking about this as one of the solutions to the MUD problem and residential access problem. And you could have, I've heard some legitimate conversations about, okay, instead of installing these chargers, we can have these, robots driving around to charge up people's vehicles at night when they don't have access to like a garage charging. So, yeah. Okay. And with that, we'll conclude for today. Quick reminder, homeworks are due at the end of the day today, so make sure to submit those.